Start here. Okay, welcome to the optical communication, and we'll learn here what will be the fibers and how this system work, optical communication system work. So in general, what happen? It is just like a information source we have. If you see the optical system, so in that case, it has an information source, and that information source can be of any signal, electrical signal there, and that electrical signal is there. It has some particular voltage. So then that electrical signal is to be converted in the form of a current. So here we use a voltage to current converter. Now this current is there, and based on this current, so we use a optical source, okay, an optical source, and that optical source, whichever the current applied to this particular optical source, it will convert that in terms of optics or a light. So that's why you can say that about a optical source here. Then a channel coupler, we have a multiple channels for this particular fiber, or we can say that is about a multiple data when we are sending. In that case, we require a channel coupler there. We will see in detail one by one. Then we have a optical fiber channel. Okay, we have a optical fiber channel. This source is there, then a coupler, okay, channel coupler, then optical fiber channel, means your light will be propagating through this optical fiber. Then we have a optical repeater. Optical repeater. And after that, we say that we consider that a detector. Okay, so we have the optical repeater in between the fiber, and then after that, at the end, we have a detector. We say that it is about a optical detector. Okay, it is about the optical detector. And then means, or we can say that a optoelectronic detector. Okay, it is about a optoelectronic detector. After that, we have a receiver, and that we say it is nothing but a optical receiver. Now here the conversion takes place. That detector, that conversion takes place. So whatever the light we have, that light is converted into a form of a current or a voltage. And then we have a receiver. Then that whatever the conversion takes place, that will convert it into a your signal. So that's why we can say it is nothing but a output device. Supposed to be we say that here information source, that information source is supposed to be a speech signal, or we can say that any any communication signal or any video signal or any source we have. That source, that signal is converted, whatever the source we say here, that source, it has a labels, so that's why we say it is a voltage. Or as per the, if it is a current one, so directly it is given to the optical source. So that's why here we say voltage to current converter. And from the voltage to current converter, once that current conversion takes place, then that input is given to the optical source. Based on the level of a current, a photon generation takes place in this particular optical source. So optical source is what? Light emitting diode, or you can say it is about a laser. So that light emitting diode, it emits a light. Even a laser again, it emits light, but the signal from the laser it will be a monochromatic. Okay, so now we'll see that what are the various signals propagating through it. Okay, what are the various signals propagating through it? So that we'll see here. So that is about a source. It can be of LED or laser. We say coherent source and non-coherent source. Likewise. So that is about a source. Then from the source we need a coupler. So coupler couple the signal through the fiber. Okay, so that's why we require a coupler. From the source to the fiber, from source to the fiber, we require a coupler. So that's why here a coupler is used, and then couple the power to the fiber, and then light is propagating through the fiber. When the light is propagating through the fiber, so whether that fiber will be of a single mode fiber or a multi mode fiber. Okay, we'll see in detail that single mode fiber or multi mode fiber. Or we can say that is about a step index fiber or a gradient index fiber. So according to that, that fiber we can use as per the whatever the informations we have. Then signal propagating through the fiber, and then if that length of the fiber is, or we can say that is a communication from transmitter to the receiver, it will be large. That distance will be large. This length will be large. So for the longer distance communication, so mostly people are using a repeater. So that's why optical repeater here, and then signal in between that line and in between that fiber, optical repeater is used. And then after optical repeater, at the end we have a detector. That's about optical detector. So that's about, we can say that is about a we have a APDs there. Okay, so that will be used as a detector there. And then it convert, that detector convert light into a form of a current or a voltage, or we can say it is conversion of a photon energy into a electrical form. That is conversion takes place. Then that electrical signal, it will be demodulated, or we can say that here we have conversion takes place to the output device. Suppose our signal is a speech signal, then your output device will be a speaker. Okay, that is about your output device. So means in general what happen here, so we have a optical fiber. Okay, now this is about your optical fiber. Okay, this is about your optical fiber, and here in between that we use a coupler. This is about your coupler, and input is nothing but a information source. This is about information source to your LED or your source here, that light source, that is LED or laser. Then we have a fiber here, coupler, optical fiber. Then in between that it is to be used a repeater, and then after the repeater, again fiber, and then end, at the end we have a detector. Okay, there will be detector. Now detector detect the signal, and then we have a receiver here, and then we have a output device. If it is a speech signal, then there will be a speaker. So likewise. So this one is about the way we say the optical communication link or your optical system. So now we will learn here what are the various types of a sources in this fiber. Our chapter consists of what? In chapter 1, what will be the ray of a light? Okay, light propagation takes place there. And then what are the types of a fiber? Okay, lay ray, and what are the various types of fiber? And chapter 2, if you see that, how your signal is propagating through this particular fiber. That's about a light. And then what are the effect of a light due to the material used in a fiber. So we learn here the various types of parameters in the optical fiber. That is about a model 2. And then we have model 3 is about a source and a detector, that we learn source and detector. And then we have a chapter 4 that is about a link budget. Link budget means what? What will be the length required for transmitting the signal from one place to another place? That is about the link budget. Okay, and then we have the measurement. So means we have chapter, or if you see that a syllabus of a optical fiber, it is divided in one by one block, and that we are learning here. And then and again chapter 6 is measurement, and chapter 5 is about it, that amplification process. What are the amplifiers we require in repeater or at a receiver? That is about it, chapter 5. So we learn here one by one. That is about it, optical fiber communication. Now come to the topic, what changes occurs in the optical fiber, okay, throughout this way what we are learning here. Okay, that is about optical fiber communication and why we are learning. What major thing happen in this optical fiber? So old days the fiber use, that is for the glass fiber. Okay, and first we can say that is about a first generation of a first generation of a your fiber, or first generation of a light use. Okay, so we can say that. So that you use in the 1970s. In 1970s, this we can say it is about a generation. And here generally we say it is about a wavelength. What will be the wavelength? And what are the various fiber types is to be used for the communication? What will be the bit rate? Then what are the fibers, and whether we have to use a repeater or not? Okay, this is about a repeater. So in 1970s, the people have used a wavelength is about a 0.85 micrometer. Okay, so wavelength is about in terms of a wavelength is always it is about a micrometer, 0.85 micrometer. And at that time in 1970s, people have used a multi-mode fiber, or we can say it is about a graded core. And at that time, people have used the bandwidth is about a 2 to 45 Mbps. And if you consider here the fiber loss for the dB per kilometer, okay, everything that length is in terms
Excuse
of
me,
dB.
sir.
Now, if you see that in 1970s, that wavelength used was a 0.85 micrometer, and this fiber is a multimode fiber that is about a graded core, and the bandwidth is about 2 to 45 Mbps, and that loss of a fiber, that is if you see that it is about a, okay, less than what we can say 1 here. Okay, so you can say that a loss here, and then repeater is to be used after every 10 kilometer. Okay, every 10 kilometer. It's supposed to be, if it is not readable, so just remember that it is about a 10 kilometer. Now there are the advancement occurs in the fiber. Then it is about a early 80s. Then early 80s we have the setup is of what wavelength is about 1.3 micrometer. Again the fiber is same. That is about a multi-mode graded fiber. Now here the improvement in the bit rate. Improvement, okay, 45 to 90 Mbps. And then loss is about 0.5 to 1. Loss is zero point 0.5 to 1. And then repeater is to be used after every 40 kilometer. Okay, after every 40 kilometer, 40. Now then in a late 80, in a late 80, wavelength changes. It is about 1.55 micrometer. Then people have used a fiber is about a single mode, single mode fiber. And then When single mode fiber is used, then bit rate changes 1.75, okay, Gbps. Instead of Mbps, it is Gbps. And that loss is approximately zero point 0.3. Loss reduces. And then repeater, that is from 60 to 70 kilometer. Now we say that repeaters use, okay, that changes now. Then early 90s, then people have used a wavelength of 1.45 to 1.622. All are micrometer. Okay. And then that fiber is about a single mode. Fiber is about a single mode fiber, and it is about a dispersion shift. It is about a dispersion shift. And then a bandwidth changes 2.45 Gbps. And that loss is again reduced to the point 2 dB per kilometer. Okay, everything is about a dB per kilometer. And repeaters to be used after 80 kilometer. Then in 2000, people are used typically 1.5 to 1.57 or typical 1.55. Typical 1.55. Okay, typical 1.55 use. So they have used a single mode one, then the dispersion shifted, or along with that, people are using a fiber amplifier. Okay, people are using fiber. And then it is about a 2.44 Gbps. And that loss is about zero point 0.1 to zero point 0.2. And then that length is increases to the 100 kilometer. Length increases to the. Now these are the evaluations of a fiber. So one by one, that people have changed. Okay, they have used the fiber there. So nowadays, if you see that a repeater is to be used after every 100 kilometer. Now come to the topic here. Now if you see that here I told you earlier it is about 10 kilometer. Okay, it is about 10 kilometer, then 40 kilometer, then 70 kilometer, then 80 kilometer, and then 100 kilometer. Now day by day advancement is occur in the fiber, and nowadays people are saying that a repeater is to be used about 100 kilometer of a distance. Repeater means what? We have a transmitter setup here. We say that this is about a fiber, and here the receiver, and that length we can say that it is about a 100 kilometer maximum. We can transmit a signal. If supposed to be, if you go beyond that length, suppose I wanted instead of 100 kilometer, so I wanted supposed to be we can say that is about a 200 kilometer, for example. Now here this is about 100 kilometer, and this is about another 100 kilometer. So in that case, what happened? For this in between that 100 kilometer, so we need to use a repeater here. We need to use a repeater. Now a long distance communication takes place through the optical fiber. But traditional method, you know that nowadays telephone line and all, they are having the limitations for the distance and all. They are using the repeater, wired communication. And in the case of a wireless communication, in the case of wireless communication, people are using a towers. Nowadays, you know that mobile phone you everyone have. Okay. But that limitations for these towers is coverage area. Or if you wanted to make a line of sight communication from one to here, one tower to the another tower. So because of that earth curvature, we could not send the signal from one tower to the another tower directly, that not beyond the 50 kilometers of a length because of the earth curvature. So we send a signal from this tower to tower communication can be possible in between only a 50 kilometer. So now if you consider the optical fiber here, the optical fiber we can transmit the signal for the long distance. So for a long distance communication, so optical fibers are used. Okay. So now as you know that, okay, as you aware about the what are the various medium, okay. So in generally what happen communication takes place. If you consider that if it is a wireline medium, if it is a wireline medium, then your signal will be in the terms of what? A voltage or current. And all these are in terms of what? A waveforms. Voltage or current waveform. If you consider that a wireless medium, okay, if it is a wireless medium, then that is called as a, what we can say, your signal will be in the form of what? A radio wave. Okay, it is nothing but a radio wave. And if you consider that a optical fiber medium, if you consider the optical fiber medium, then your signal in the form of what? A light wave. Okay, so that is called as, we can say, that is about your signal, and your, we can say that a what will be the medium. So wireline medium is wire communication. We have the signal in the form of waveform that will be related in terms of a voltage and current. If it is a wireless medium, then your signal will be in terms of a radio waves. Means we can say mobile communication, that is nothing but a radio waves. Optical fiber medium, so we can say that light. Means light will propagating through the optical fiber. Now in the electromagnetic spectrum, if you consider that, so in that case, we have the way for what? Infrared light. Generally we say infrared light. And that infrared light is to be used for the 300 gigahertz to 300 terahertz. Okay, 300 gigahertz to 300 terahertz. And if you consider the wavelength, so that is about 1 mm to 1 nanometer. And application is about what? Infrared LAN. Infrared LAN. Or you can say that is about any consumer applications, or you can say that is about astronomy in that case. But in the case of a visible light, that frequency we say it is about a 400 to 750 terahertz. Okay, and that wavelength is about a 0.75 nanometer to 0.40 nanometer. And this is nothing but what we can say your optical fiber work. This is about your optical fiber. So if you consider that earlier we say that electromagnetic spectrum, we say that will start from the hertz, then kilohertz, then megahertz, then gigahertz. So then we have a terahertz and all. Okay. So likewise, here your optical fiber communication will work. So means if you say that Okay, in this particular case here, we say that a electromagnetic signal, okay, that will be propagating higher that this particular frequency, that is about a 300 gigahertz, we say, above that 300 gigahertz. That will not called, generally it is not called as a radio waves. Okay, they are not called as a radio. These frequency signals are called as a, that is rays, and that rays can be what? These rays can be what? We can say that it can be of what? A X-ray. Okay, we can say that it can be of a gamma ray. Okay, or we can say that it can be of a cosmic rays. Now, cosmic rays means what? It is used for the study of a astronomy. Okay, so that's why we can say that this particular frequency signal, infrared light, can be used, infrared light. That is, these are the frequency range. You can study in terms of gamma rays, okay, X rays, or a cosmic rays. And we say that a radio waves, okay, whatever the radio waves we say, word, that radio waves. That radio waves are what? It is are invisible in nature. Have you seen? Sorry, radio waves are what? It is about the invisible in nature. But in general, we say that a light waves. Whereas what we can say that whatever the light waves we are using here in optical fiber, light waves can be seen. It is nothing but we can say it is about a visible one. Or we say a heat waves. Okay, we could not see okay heat waves, but we can observe. Okay, we can understand it is about a heat wave. But radio waves we could not see. We could not understand that there is a radio waves present. But a light waves and heat waves, if you see that, sometimes heat waves can be visible. Okay, okay. So, but heat waves can be observed. Okay, so that's why I can say that heat wave can be observed, or we can understand that there is a heat wave. But radio wave we can't. So we need to learn about what will be the light waves and what will be the light wave spectrum. So instead of understanding that electromagnetic spectrum here, we'll understand that for our optical communication, or to understand how that optical communication takes place, we need to understand that what will be the light wave there. Okay, so what will be the light wave? So we come back here for the light wave, how to understand that whether there is a light wave or what will be there. So we need to learn about a light wave spectrum first. Okay, that is about a light wave spectrum. So generally we say that a light wave spectrum is divided into what? A infrared, or we can say that is about a visible, or we can say that is about a ultraviolet. Okay, so we can say that a light wave spectrum. Now, so in case of a infrared, if you take an example of an infrared, okay, if you take an example of infrared, so that frequency is, or you can say that about a light, that wave, that infrared light wave cannot be seen. Okay, that infrared light cannot be seen by the human eye. Okay, infrared light cannot be seen by the human eye. And it is about a generally that wave is, we can say that is about it's quite high. Okay, but in terms of that visibility, so it cannot be seen by the human eye there. And it has a range of what, a 770 nanometer to 1600 nanometer. Okay, and this particular range of this infrared light 177 nanometer to this range, so this range is to be used in a optical fiber communication. But what happened, this in this particular frequency range, that fiber, or you can say that a glass fiber, silica glass fiber, they are attenuating their signal in that particular range. So then in which values or in which wavelength that attenuation will be a minimized. So that's why they have some particular band or particular range. So at that particular band or at that particular wavelength, the attenuation is less. So that band or that particular value of a wavelength is 850 nanometer, 1300 nanometer, or we can say that is about 1550 nanometer. And what happen here? So they can use, we can say, a silica. Okay, it is about a silica glass fiber, silica glass fiber. Okay, or we can say that this particular range of frequency, that's your communication, or you can say that is about a fiber communication. Okay, this particular band of frequency, your optical fiber communication. Okay, that can be takes place here. Or means we can say that your optical fiber operate or your fiber operate in this particular band of a light waves. Then next about a visible light. Next about a visible light. In the case of a visible light, your wavelength will be what? A 390 nanometer to 770 nanometer up to this only. But what happened? It will be a visible to human eye. It will be visible to human eye. Then we can use this particular device for this particular visible spectrum. But we could not use a silica glass fiber. Silica glass fiber cannot be used in this particular band of frequency. Or you can say that this visible light is not good. Okay, this visible light is not good for transmitting the signal through this band of frequency. Okay, through this visible glass fiber, through this glass fiber, silica glass fiber. So means this band will not support by this fiber. Why? Because when we use this particular band of frequency, okay, band of a signal, and that signal propagating through the fiber, so all signal will get attenuated. So means attenuation takes place. So that's why for the longer distance communication, so this cannot be used. But only if supposed to be it is a short distance, small distance. Okay. For a short duration, short distance, for short distance. Optical communication. Okay, for a short distance, optical communication. Okay, this visible light can be used. Then next about a ultraviolet. Okay, ultraviolet. So in that case, it can be seen by human. Okay, ultraviolet light, it can be seen by the human. The range is about 10 nanometer to 390 nanometer. But what happened there? Losses are more. Here the same losses are there. But we can use for the small distance communication or short distance communication. Means what losses? That is about the fiber losses. So that's why this particular band is to be used in a medical application. This band can be used in a medical application. Okay, but if you supposed to be use a fiber, then losses are there. But other than that, this band, ultraviolet light, can be used for the medical application. Nowadays, you know that for the treatment or for any medical use. Okay, so this particular ultraviolet light are used. Generally, you know that laser treatment. Okay, so in that case, that medical application, this laser that will work in this particular band of frequencies, that can be used. There are some standards. Okay, so which frequency band is used, what will be the duration of that particular light is to be supposed to be imposed on that particular object. Okay, so that is to be seen here. So that is about your ultraviolet light. Okay, so we can say that this particular light rays or light years, so we can consider here. So we need here to understand that what specific band of frequency we are using. Either this, we'll see that these are the specific block of frequency or wavelength which mentioned. So what happened to the attenuation? We'll see the attenuation diagram there. Then optical bandwidth. Generally, what happened in general, a bandwidth we have defined in terms of a frequency. I can wait.